Hi, in this video we will dive into the Git basics. This video is taken from our full Git and GitHub, the practical guide course on Academine Pro. You can find a link to this full course in the video description, of course at a special discount. If you just want to get started with the basics in Git, well, then this is your video, so let's dive into it. Welcome to this course, great to have you on board. Now this course is about Git and GitHub. Getting started with these tools can be a bit cumbersome sometimes. Both tools come with their own language, so to say, so we use commands to interact with these tools, and also the logic under the hood, so how Git and GitHub actually work when applying these commands, is not that easy to understand if you're just getting started. Now this is where this course comes into play now. In this course you will learn all the core commands you need to work in your own projects with Git and GitHub, and we'll also have a look under the hood of Git and GitHub to understand why a certain command has a certain impact. With that, you are well prepared to work on your own Git and GitHub projects, and this means we actually shouldn't waste any more time. Let's dive right into the course and let's get started with the most important question first. What and why? What are Git and GitHub and why should I use these tools? Let's dive right into the course and let's get started with the what and why. So what are Git and GitHub and why are these helpful tools, especially for us as developers? Well, Git and GitHub are two separate tools but have a close connection with each other. To dive into Git first, Git is a version control system. What does this mean? Well, Git allows us to manage our source code and to track changes in code history. This is quite awesome because it allows us to save different versions, different prior versions to be more precise, of our code and to then keep on working on later versions of it. Once you have a certain stage of your project and you want to jump back to an earlier version of your code, for example to check out a specific feature which was implemented back then you can easily do this. It has a lot more features of course, but that's the core idea behind Git. Git is a local tool though. It's a free tool you can download to your computer and we'll do that throughout the course, but it's actually meant for working in a local development environment. Now, if you're working on bigger projects, you typically work in teams where everybody has different parts of the code, of the website, for example, he or she might be working on. Now for this, we need to bring our local Git project to kind of a, more dynamic, better accessible, maybe even a cloud environment. This is where GitHub comes into play, because GitHub is a hosting and collaboration provider specifically made for Git repository hosting. A Git repository is a folder, a project managed by Git. We'll dive into that, of course, throughout the course. But the idea is that you can then take your projects from the local environment to the cloud and with that enable all these great collaboration options you typically need in your daily work on your daily projects. Therefore, GitHub allows us to bring your local projects from Git to a server-based solution, a cloud solution in the end, and therefore enables the perfect connection between these two environments. This, of course, allows us to have great options when it comes to collaboration with other people in our teams and a lot more. One side note here maybe at this point, Git and GitHub are mainly made for developers, and that's also the focus of this course, but these tools are not limited to these. Theoretically, you could also manage your Word documents with Git, just to give you an example here. So this is the what. What are Git and GitHub? But we have to take a closer look at the why, I guess. Well, and to understand the why, we have to think about this Word example maybe once again, or about a simple text document example. If you think back about the times when you were at school, or maybe you are still at school, then you might work on an essay. You write a text file and you have different versions of it. What typically happens is that you are creating multiple copies of your files. So you have a folder which stores your documents, and you have the first draft, the second draft, the third draft, draft 4, and so on. Lots of drafts until you have the final version of your document. So you create lots of side copies to make sure you don't lose any prior progress or any prior things you wrote. You might want to jump back to these. You can do it like this, of course, we all did, but it's not the most clean way to do this. An alternative could be that you simply work with a single file only. Again, you might have your folder, and this folder just contains the final version in the end. This is also possible. The problem is that if you find out at the end that in draft 20 you had a great paragraph written, well, then this is lost, so also not the perfect solution. This is where version control systems or version management in general comes into play. Because with this, you would have your folder, and this folder only contains one single file, so not all the other drafts you had before, but the other drafts are still available. Because with Git, you can check out, this is what you call it if you jump back to another version of that draft here, the third draft or another draft. But in the folder, only the latest draft will be displayed, so you will only have one single file in that folder. So therefore, version management or version control systems allow you to combine the single file option you have with the single file only approach with the copying file approach in the end without having to copy that file. So with version control systems, we can easily keep track of our changes, jump back to earlier versions, and we can at the same time keep a clean structure. Of course, Git, and especially in combination with GitHub, is not limited to these features. It actually comes with lots of helpful tools to make your daily life as a developer a lot easier. Now with that, let's not lose any time, let's explore what's inside this course, and let's then jump directly into the topic. What is this course all about, how is it structured, and what will you learn? We are almost done with getting started, and in the next optional module, we'll dive into the Mac terminal and Windows command prompt basics. Command line based computer interaction, this is what these two tools are all about, allow us to tell the computer what we want to do just by using simple commands. Typically, we have a graphical user interface to interact with the computer with the mouse, for example, but working with Git also means working with the command line. Therefore, in this module, we make sure that you know how to use your Mac or your Windows machine with this command line. After that, we'll dive into Git and we'll get started with the basics. Basics means we'll of course install Git together on our machine and we'll dive into all core concepts Git has to offer. This means we'll understand what the working directory is, what the staging area or the index is, what the repository is, how commits work, how branches work, how you can create these, how you can delete these, and a lot more. So towards the end of this module, you will be ready to work with Git already. But there are some more advanced concepts to understand if you want to dive deeper into Git, and that's exactly what we will do in the following module. This deep dive module will focus on two concepts like the git stash or the reflog, which allows us to bring back deleted information or lost information in the end, and we'll also dive deeper into combining content from different so-called branches. Specifically, we'll have a look at commands like git merge, git rebase, or we'll dive also into cherry picking. This deep dive will make sure that you really understand the internals of how Git works, and this will make you ready to really use it in also slightly advanced projects. With that, our local work on our machine in Git will be finished. This will mean in the third part of this course, we'll bring Git to the cloud with GitHub. So in this module, you'll learn all about Git and GitHub and how these two are connected. We'll dive into concepts like remote repositories, remote branches, remote tracking branches, local tracking branches, git clone, git push, git pull, git fetch, and a lot more. So basically all you need to bring your local projects to the cloud in GitHub. So this is what this course is all about, and if you know how to use the terminal on the Mac or the command prompt on Windows, then you can directly continue with the basics module about Git. Otherwise, see you in the next module where we'll refresh the terminal or the Windows command prompt basics. Welcome to this module. In this module, we'll finally dive into version management with Git and we'll start with the basics. These basics will include an introduction into the theory. So we will have a look behind the scenes and learn how Git works internally, how it does all this version management thing. Besides that, we'll of course have a look at the Git installation and at our development environment. So we will set up our environment to make sure that we can work with Git correctly. And we'll also have a look at repositories, branches, and commits. So we'll dive into the Git command basics. That's it. Let's get started. How does Git work? Let's have a look at Git in a simplified way first. So we could say we have a project on our computer, a folder named webshop because the project is about the webshop. In this folder we have some files, an index.html file, a style CSS file, maybe an images folder containing some images, could be anything like this. This is the current state of your project, so you just got started. Git is not involved at this stage. Now you want to save this project as a draft, you could say, and then continue working on it without losing this first draft. So you want to have this first draft and then your next version. As explained in the first module of this course with version management tools, this can be done easily. So what we will do then when using Git, we will turn this whole project into a so-called working directory. This simply means that we can now use Git commands to manage this project with Git. At this stage, nothing happened though. To save our current state of this project now, we have to create a so-called commit. A commit can be simply remembered as a snapshot, so our first snapshot of this project. And we will then do this via Git. So a commit is a specific thing that we have available now in Git. And this commit, and with that, this project status will then be stored and managed by Git. We can then continue working on our project. Let's say we don't work on the index.html file or on the images folder. We just work on the style CSS file, for example. And then we say, now the style progressed, let's save another version of our project. This means we will create another commit, our second snapshot. And now Git will only save the changes made to the style CSS file. That's very important to keep in mind. Git does not always save the entire files. That would not be efficient and would use a lot of memory on your hard disk drive. Therefore, Git only tracks changes. So Git knows the initial state of the style CSS file and now knows the next state, so it saves this state. The other states for the index.html file and the images folder, of course, are also still available. Then we can continue working on it. We could create a third commit, our third snapshot. This could mean that we add a script.js file, a JavaScript file. And in the end, we would have 3 different commits, 3 versions of our code, which could always be accessed, so we didn't lose any state of our project. Internally, Git stores all these things in the so-called master branch. That's the third Git-related term we have on this slide. So we have this working directory, we have a commit, and we have this branch thing. Now, this means at this stage, we have to dive a bit deeper to really understand how Git does all these things. For this, we'll have a look under the hood of Git, and we will again get started with this working directory. As we know, this is basically our project that we have. Let's say we did our first commit in this project, and now we will do a second commit. I highlighted the style CSS file. This means we basically want to tell Git that this file was changed here, and now we want to save the changes made to this file. For this, we have to understand a so-called Git repository. Now, this is another new term for us. The Git repository is basically a .git folder, which was created when we initialized Git. So basically, when we told Git that it should manage our project in the end, and at this point, this folder was created. In this repository, we have 2 different areas. We have a staging area, it's an index file, and we have our commits, that's the objects folder. You can find this file and this folder in this .git folder. These 2 parts are crucial for our actual version management in Git. The working directory is just the area with all your files. So basically where you add your files, where you change files, where you delete files. So the entire project, so to say. In this repository with the staging area and the commits, the real version management part happens. That's where Git is really active. Now let's say we want to tell Git that this style CSS file was changed and that we want to save the changes made to this file. So to do this, we first add, that's a Git command, we add the style CSS file to our staging area. The staging area is just kind of a draft area, you could say. So we can add different files to this area, but these files are not yet included in a commit. This means the version changes are not yet saved. So you could say you now add the style CSS file, then you start working on the index.html file, and once you're done with your changes there, you also add this file to your staging area. You would then have 2 files, the style CSS file and the index.html file right there. Once you're done and you say, yes, now I want to save these changes as a new commit, as a new version of my project, you can commit these changes and with that create such a new commit. With that, the new version of the style CSS file will be stored as a commit. Now, very important to keep in mind, I mentioned this earlier already, Git is tracking the changes. It's not storing the files again and again. This would not be very efficient and also wouldn't make a lot of sense as we only want to track our changes. We don't need to save the entire files again and again. So these are working directories, commits, and this repository. There is one last term we have to understand before we dive into Git, and that's this branches thing that we had on our last slide. Branches and commits are closely related. Why is this the case? Well, let's again think about our working directory or also the working tree. You will find both terms in the real world. Now in this working directory we have our webshop folder with the files and the folder, just the structure that we had before. If you just create commits as we did it, then this working directory will be part of the so-called master branch. It's basically a separate project within your Git project, so to say, and this master branch then contains all the commits, so the first one, the second one, and the third one. Now, think of this master branch as the main project, so that's the finished website, for example. You say, yeah, it's working now, it's perfect. This master branch is nice, but what if your website is live already and you now want to work on the landing page of your website? You could do this in the master branch, but you don't want to break it, right? It would be better if you could have a separate copy of that master branch, then implement changes on your landing page in that copy, and once you're done with the landing page changes, you then, well, kind of add it or merge it to the master branch. That's exactly the concept behind branches. With a branch, you can create a whole copy of your working directory, so with the folders and the files as we had it before. But this branch is now not the master branch, but it could be the landing page branch, just to give it a name here. And this landing page branch contains all the previous commits you had. But if you now add additional code, additional files, or if you change it in general, then these changes will only be applied in this landing page branch, but not affect your master branch. This means you could add another folder containing other files and so on with all the data related to your landing page and also with dedicated commits, not only one right here, this could be multiple commits. And once you're done, you add the changes to your master branch. So these are all the core terms that we have in Git. At this stage, it might still feel a bit strange as we didn't use Git so far, but I think it's very important to keep this theoretical structure in mind before you actually work with Git. We'll of course revise these concepts when we use Git now though. With that theory out of the way, it's now time to dive into Git. So in the next lecture, we'll install Git and we'll set up our development environment. Let's install Git now, and for this, well, we can simply Google it right here, and the first link is the right one, so this git-scm.com. Let's select this, and now we are on the official Git page. The download is very straightforward here. You can just go into this latest source release. In my case, this is the one from July 2020, and then download it either for your Mac or Windows device. So let's click onto download here. Once the download is finished, just open the exe file which was just downloaded, and then this pop-up window will open. Here we can just click next. Here you can specify the folder where Git should be installed. I'll just choose the default one here. Here you can just untick the Windows Explorer integration as we don't need this at the moment. The other options can be ticked. So let's press next here. Same thing right here. Here we can also leave the default option. We will use Git from our terminal, therefore this is not required for us. So you can also just use Vim right here and we'll click next. And here we'll select the second option, the recommended one, so the default selection is also sufficient for our purposes here. And the default option, use the OpenSSL library, is also fine at this stage. And here, it's important to check this first box. This is not important when we work locally on our Git projects, but later when we work with GitHub and when we collaborate on projects with Mac and Windows users, it's important to select this option. I'll dive into this later in the GitHub module, but for the moment, just check this option and click next right here. And here we'll not use the first option, but the second one. We will use Windows default console window. We will work with the command prompt in this course. I mentioned this in the first course module. We want to make sure that everybody, not only Windows 7 or later users, can work with Git here easily. Therefore, let's select this second option and press next right here. For Git pull, we can use the default behavior. We don't need any credential helper at this moment, so we can select none at this point and press next once again. Caching can be enabled, this is all right, so let's press next right here. We won't add any experimental support per sudo consoles. We leave this box unticked, and now we can finally install Git. So you saw lots of options to be set or unset right here, but as you saw, for the majority of the options, the default selections are totally fine. And also throughout this course, we will get to know the most important options, so no worries at this stage. We don't want to see the release notes, and we also won't launch the Git bash right here. So we will just press next, and with that, close that window. Now, just press the Windows key on your keyboard and open the command prompt right here. And now in the command prompt, enter git -- version, like this. With that, you should see the Git version installed on your machine. This means we can now access Git from our command prompt. We also installed the Git bash. Let me show this to you right here. So the Git bash. This is a specific shell, as also mentioned in the first course module, that can be used when working with Git on Windows machines. But as said already, for the course, we will work with the command prompt here. With that, Git was installed successfully. What's missing at this point though is a code editor, an IDE. Because in the next module, we won't have a very big course project, but we still will work with files and different folders. So working just from the terminal is not very convenient. Therefore, we will install an IDE. The IDE we're going to use is Visual Studio Code. You can find the name right here, and then this code.visualstudio.com is the right link. So let's open this page and make it a bit bigger for you. And I recommend to use Visual Studio Code right here as it's free, which is nice. It has cross-platform support, so you can use it on Windows or on the Mac, for example. And it comes with an integrated terminal or command prompt on Windows or on Mac. Therefore, as we work from the command prompt in this course, well, that's of course great to know. With Visual Studio Code, we can easily manage our project and our files, and we can execute our Git commands. Therefore, just download the stable build, so this link right here for Windows. Download starts, you can see a little getting started guide here, but we won't need that. I will guide you through the basic features in this video. So once the download finish, open this exe file as we did it for Git a few minutes ago. Now the installer opens. We first have to accept the agreement here and press next. Then we can use any folder where Visual Studio Code should be installed. I'll go with the default one right here and select next once again. Here we can also take the default value, and here, only one option should be ticked, and that's this last one, add to path. Add to path simply means that our command prompt or our terminal on the Mac can be used in Visual Studio Code, so that's important to use. So let's tick this box and press next once again. And with that, we can start the installation finally. Shouldn't take too long, so let's wait a few seconds. And now we'll finish the installation. And with that, Visual Studio Code is open for the first time. Let's first close some information down here. And let me first zoom in a bit with Ctrl and plus to make sure the readability is a bit better for you. I think this is nice to read here. And now we have this welcome screen. I'll close this screen for the moment by clicking right here. And now we can have a look at some basic options here. If you never worked with Visual Studio Code before, I recommend a video on our academind.com website. You can find the link attached to this lecture. Here we'll just have a look at the very basic features. So here we have basically access to our project, search capabilities. Here we even have integrated source control, which will not be covered at this stage of the course. But most importantly, we have our project here, which will open soon. And here, if we go to view and to appearance right here, then we have the option to show our panel. If we do so, this panel here is displayed. So basically we have our PowerShell integrated here. And as we learned in this course, we don't want to use the PowerShell. We want to use the command prompt in this course. For this, we have to click right here and then say select default shell right here. Now you have three options. You have the command prompt, the PowerShell, which is currently selected, and the Git bash. I mentioned this already. We will just use the command prompt as I said. So let's select this first option and confirm it with enter. Now nothing changed, but if we now click onto this plus symbol here, a new command prompt is opened, and we can now go back to our PowerShell and click on this remove symbol. With that, we only have the command prompt in here. What's missing here is our project folder though, because at the moment we don't have any project files in here. For this, let me quickly switch to the desktop. And here I'll create a new folder right here. And I'll just call it initial project like this. And now we can go back to Visual Studio Code. And here with open folder, We can now navigate to the area where you created this folder. In my case, it was the desktop, and now we select the folder. And now we have access to this initial project. You can see it right here. We can again close this welcome screen. And once again, we can now open our panel, which is now the command prompt as set up before. You can make it smaller or larger as you prefer. I'll maybe zoom out one step more. I think now things are better readable. That's it. This is our project setup now. We installed Git, we installed Visual Studio Code. This means we can now finally get started. So in the next lecture, it's time to get our project started and to work on our first Git commands now. Let's dive into the Git basics now. Quick side note, I renamed the project folder to Git basics. You can do the same, but you don't have to do so. At the moment, we have our empty project folder, which doesn't contain any files, and we also know that Git is globally installed on our machine. We can check this with git -- version, we know this already, so that's what we have. So basically, Git is available. Let's now see if it also works in our project. For this, we can create a first project file, so we navigate right here, click New File, and now call it maybe initial commit, because it will become our initial commit. .text, so a simple text file here, and this text file can contain some, text, let's say our first step in Git, like this, and let's save it. At the moment we have installed Git on our machine, so let's maybe try out one Git command to see what we can do now with this file, with this project. We already saw a Git command a few seconds ago. This was this git -- version command, and it showed us that Git commands always work with the git at the beginning and then, additional information about which command we want to run right here. A typical and very helpful command in Git is git status. Git status always gives you information about your working directory. The working directory is the project folder with all the project files in it. We had a look at that in theory already. Now we can enter git status like this, and if we do so, we get an error message. We don't have a Git repository in our current project folder, so in the Git basics folder, or in any of the parent directories. Let me bring this back to your mind in theory quickly, because on this slide we kind of had the situation. We said that Git consists of our working directory with all our project files on the one hand, and of this .git folder, this hidden folder, which is our so-called repository. And the repository contains additional data, but the most important ones for us are the staging area with this index file and the commits in this objects folder. Now, in this structure is required if a project should be managed by Git. If we quickly go to our project folder here, and there go to view and show our hidden items, you see that we only have the initial commit text file. We don't have a .git folder, therefore this at the moment is not a working directory, it's just a plain folder, and we also don't have such a repository. To turn our project into a working directory and to add this .git folder, we have to run another git command. We have to initialize the repository, and we can do this with git init for, initialize. If we do so, we see that we have the confirmation here that this repository was initialized, and we also get the information right here to the left in our integrated source control in Visual Studio Code. We won't dive into this part of VS Code at the moment, therefore to avoid any confusion at this stage, we go to View right here, Appearance, and there close this activity bar. This makes it easier to avoid confusion here. We'll dive into the Git features without this helper at this point of the course. However, with the initialized Git repository, we now have our working directory, and if we switch again back to our folder, you can see that in this folder, we now have this, hidden .git folder. Therefore, this is our repository. This and all other files and folders right here are now a working directory. With that out of the way, we can now add our initial commit right here to the staging area and then create our first commit. Now again, sounds a bit confusing. Therefore, let's again use git status as we previously tried it. And now we get some important information. First, we are on the master branch. Branches will be covered a bit later in this course. For the moment, we can just say that inside our project, we have one so-called branch, this master branch, and this master branch contains all our commits. So it's basically a folder containing all the commits. Not a real folder, but I think it's easier to remember that for this moment. So let's take this as given. The next information is that we don't have any commits yet, so no snapshots are stored in our project here in this master branch. but we have untracked files right here. And this is our initial commit text file. That's the file we created. So we see with our git init, Git is now aware of these untracked files in our working directory, but we now have to add these untracked files to our staging area. How can we do this? Well, we get the information down here. We can simply use git add right here. With this, our files will be tracked. And this, in other words, means these files or this file here is now part of the staging area. To add a file to the staging area, we need another git command, and this is called git space add. Now, add can be written in different ways. The most common ones are either git, another reference to the files we want to add to our staging area. So for example, git commit.txt. With a space, we could add other files we want to include, or we simply use git add, now a space and a dot. This will simply track all our files in the project folder, and with that, add these to the staging area. That's what we will do at the moment. Doesn't make a difference as we only have one file either way. So let's do this. And now let's again use git status. Let's see. Now we see, again, we have no commits yet, but we have changes to be committed. And specifically, this is the new file we added to our staging area. So that's important to keep in mind. If we go back to the slide one last time, what we did now is we took our single file, used git add to add it to our so-called staging area. And now the next step is to use another command. This is git commit, and then finally to add it as a commit in our objects folder in a repository. This will finally create our snapshot. So back in the project, let's now commit this file. And to do so, we type git once again. You know how this game works in the meanwhile. Now we take the commit command and now a space. Now -m simply stands for message. So each commit has a specific message to make clear what exactly changed with this commit. And you add this message with quotation marks. And here you can simply type added first dot text file, maybe like this. If we confirm this, we get an error. So this is not working because Git wants to know, well, who we are. Specifically, we have to add an email address and our username. This is our account identity, as you can read right here. So it's very important to add this so that other people know who created this commit. Otherwise, it would become, well, kind of a mess if anybody randomly and anonymously would add commits. Therefore, it's important to identify yourself. We also get the command up here that we have to use, so git config once for the email and the second time for the name. You can omit this global part right here. This would then simply add your credentials to this individual Git project. With the global part being added, this will mean that your credentials are stored for all projects on your machine. That's also what we will go for. So we can quickly copy this right here, paste it down there, and now enter your email, please. I'll do the same for myself here. And now again, use this command, but this time not for the email, but for the name. And here we enter our name. And if we confirm this, we see nothing because of course we again have to commit our changes. So let's add git commit -m added first text file. And with that, we now created our first commit, which now got confirmed down here with this message. So this was our first step in here. We created this commit, but so far we cannot find out too much about this commit. So we should dive a bit deeper here. So what about this commit? Well, let's first clear this here and let's run git status once again. In git status, we can see we have nothing to commit. Working tree or the working directory, I refer to both interchangeably as I said, is clean. So that's nice, but where is our commit now? Well, we have a command in Git which gives us access to all our commits in our current branch. I said that we are currently in this master branch. The command I'm referring to is git space log. This one right here. If we do that, you get some information here. The most important information here is this commit ID up here. This is a unique ID for each commit you create. So with this ID, you can refer to exactly this commit. This makes it easier later to specifically load or check out, as it's called, a specific commit. Besides that, we get information about the author. That's the information we just added in the last lecture. And you get information about when this commit was created. And you also get the info about the commit message that we added to this commit. So that's nice, but it's only one commit, right? So let's maybe change our project a bit to have at least a second one, and then we'll have a look at this once again. So let's now create another file, maybe with our second commit.txt to be in line with this a bit. And here we simply add the text. This is our second commit. And save this. Now we know how things work. If we now again run git status, right? You see that we have untracked files once again. So Git is now aware of our initial commit text file. We didn't change a thing in here, so it knows this file and it's not untracked. So we have the latest status of this file tracked in our staging area, but we have created this new file, second commit.txt. Therefore, we have to run git add once again, and now we can refer to this file individually with second commit.txt. Let's do that. If we now run git status once again, you see that we have a new file which contains changes we can now commit, and to commit changes, we once again run git commit -m added second text file in here. We did that, all right. So let's now jump back to our git log and dive a bit deeper. Because here we can now see both our commits, right? We can see the latest commit always on top right here, also again identified by the message. We can see the date and so on. And here we have our first commit. Now the cool thing about version management now is that if we want to go back to our previous commit, we can simply copy this ID. Now type git, and now to load a specific commit, I call it load right here because it's actually called to check out a commit. That's the Git terminology. So you check out, right, a specific commit, and you simply add the ID. If you do so, you see something interesting. You see that our second commit up here, which was open, is deleted, so it's no longer available. But we are back at the status we had when we created our first text file. But where is our second commit now? Was it deleted? No, it was not. If we go back to git log, the second commit is also not here. So did we lose it? No, we didn't lose it. You remember that we are in the so-called master branch. And if we now simply run git check out, and now not the commit name, but the branch name we are currently working in, well, this is the master branch, then suddenly our commit is back. And if we once again run git log, we are back with both of our commits. Now this was confusing at this stage, right? Therefore, in the next lecture, we'll dive deeper into branches. Because to understand Git, you have to understand the working directory, the repository, commits, and branches. Before we dive into branches, let's have a quick look back at the slide we already saw, because we learned that a branch basically is a unique set of specific code changes. Now, it sounds a bit strange, but if you think back about our current state in a project, we have our working directory with our commits, and these commits are in this current master branch. So this branch holds all these commits. The master branch is, by the way, the default name for the first branch you create in Git projects. Now, as mentioned in the theoretical example earlier, if you want to start a side project or add additional content to your current project, you might want to create a complete copy of that existing branch, work on that copy, and then later implement the changes you added to this copy to the original, to the master branch. So the goal now is to create such a copy of the master branch. In this case, we called it landing page branch, and then we want to add some additional folders maybe or files and additional commits. Later, we'll then have a look at how we can add these changes to the master branch. So keep that in mind. We have currently our master branch, which we'll now copy and then continue working on our project. Back in our project, let's first have a look at our current branch, this master branch we are working on. Generally, you can get an overview of all the branches you have in your current project with the git branch command. If you run this, you see we only have this single master branch at the moment, indicated by this green highlighting and by the asterisk right here. Now, as I said, this is the default branch that is created with our first commit. We can also create additional branches here. For example, here we could say we have these 2 text files in our initial master branch. Now we want to add a third text file, in this case, in a separate branch. As mentioned, this could be such a new feature you want to implement. To create a new branch, we can again use the git branch command, but now we have to add the name of this new branch that we want to create. In contrast to the commit messages, we don't need to use quotation marks here, but the branch name must not contain any spaces. Therefore, we could call this simply second branch with a dash. Of course, these are not typical names you would use in your real-world project. Here it's just for demonstration purposes to understand the general logic behind Git. With that, we see nothing, of course, and nothing changed here. But if we now again run git branch in here, you see we now created this second branch down here. Currently, as mentioned before, we are still in our master branch. To access this second branch, we do what now? Well, we use our checkout command we already learned. We can use this for commits also, but actually checkout is made to switch between different branches. We have different branches now, therefore we can just run git checkout and here refer to our second branch like this. Now you get the confirmation that we switched to the second branch, and if we clear this quickly, we can now see that this second branch is exactly equal to our master branch. If we run git log, we can confirm this. So you see we have our second text file added and the first one. So it's exactly the same structure that we had in our master branch. And very important, a bit later, we also have the same IDs for both commits in the master and in this new branch we created. This will also become important when we talk about this head thing right here. Let's ignore this for the moment though. With Q, we can leave the log right here. And now before we work on this second branch, I would like to show you an alternative way how to create branches. Because instead of using git branch and the branch name and then checking it out, you can also find a kind of shortcut for this type of operation. And the shortcut is simply git checkout like this, and now -b, so this basically creates a new branch and checks it out immediately. And what we need, of course, also here is a branch name. Here I will call it third branch, as I said, not the typical naming convention in a real-world project. If we do this, we see we switched to a new branch named third branch, and we also created this new branch. With git branch once again, we can confirm this. We now have 3 branches in our project, and we are currently working in this third branch here. Now, being in this third branch, we can also add changes to this branch. I will again create a new file right here to make it easier to understand what is happening. So let's create this new file, and let's call it working with branches.txt. Right here, and here we could add some messages if we want to. Now we know how branches work. We can save this. And now, as we have a change made, we can of course add this change to our staging area. We say git add working with branches.txt. Now it's added, and now we can commit this with our git commit command, -m for the message, and now added branches text file, for example. If we do that, no big surprise, we can run git log in our newly created branch, and we see we have this added branches text file, and we also have our first 2 commits. So that's the same thing we had in the second branch we created. If we create a new branch based on another branch, then all commits will be taken into this new branch. Another side note, you see that had changed here, so definitely something we should dive deeper into in the next lectures. However, we can now quit this here, and as you see, we have these 3 files in here now in this third branch. If we now go back to our master branch, for example, with git checkout master, like this, you see that the files are gone, and this is deleted, so it's no longer available here in my IDE. And with git log, oops, not in here, and with git log, we can again see that in here, we only have these 2 files. So the added commit in the third branch is not reflected in here, as we work in separate branches, separate copies of our project, so to say. Now that's interesting, but what if this addition that we had in our third branch, so this new text file, is something that we also want to have in here in our master branch. As said already, this could be an additional feature implemented to our website, which is now finished and which should now be added to the master branch, so to our website in the end. Well, this is a feature called merging. We'll dive into this in the next lecture. How can we merge different branches? I mentioned it already. The idea behind merging is that if you work on a separate feature in a separate branch and you finish this feature, you can then kind of combine both branches, in our case the master branch and our third branch, and with that add such a feature to your master branch, which is typically the branch containing your project, for example, the website. Now, let's first quit our log here and clean the screen or clear the terminal. And the git merge command works pretty straightforward actually. You simply run git and now merge, but now very important, you are located in the branch where the additional information from the other branch should be added to. Now, as I said, we want to add our third commit to our master branch. Therefore, at the moment, just to show you this once again, I'm here in the master branch. So now we can simply say that we want to merge the content from our other branch into this master branch, and we do this via the git merge command and now referring to the third branch in here. If we do that, you see, we now have suddenly 3 files here in our master branch. And again, to show you this, we are still in the master branch. If I log this quickly, you see that we now have our edit branches text file commit here and also the other 2 commits. So now we have 3 commits here in this master branch, and we added the data, the content from our third branch into this one. However, we still have an issue here. We have this head thing I was talking about in the last lecture quickly. We have right here something with head. Here we have that green highlighting with second branch. So what about this right here? Now, let's explore this in the next lecture. And with this course excerpt comes to an end. You now saw a lot of basic commands you need to use Git, and if you want to dive deeper into Git and or GitHub, then you can find the link to our full Git and GitHub, the practical guide course, in the video description. Would be great to also welcome you on board of this full course, and otherwise I hope to see you in one of our other videos. Bye!